Good morning, esteemed professors, and welcome to an exciting new experience with the Science Bus. Today, we shall be exploring an experiment focused on calculating the oscillation period of a pendulum. Therefore, it is an experience that is quite suitable for high school students. For conducting the experiment, we will require the mechanics kits. Let's begin by securely mounting the vertical rod through screwing it into the base. We then take the clamp and carefully insert the shorter rod into one of the available slots. We ensure it is tightened properly. In the other available slot, we will cautiously insert the vertical rod. We ensure that everything is tightened securely. Now, we proceed to take a weight along with some string. This is a weight of precisely 50 grams. We carefully cut a segment of wire and create two loops at its respective ends. In one loop, we will securely insert the weight. In the other loop, we will insert the support rod. We secure everything with a small knot. Utilizing the scissors, we meticulously trim the surplus thread, and at this juncture, employing a measuring tape, it becomes essential to precisely measure the length of the thread. Let's proceed by taking the protractor and carefully aligning it with the string. Gently move the pendulum to an angle that is less than 15 degrees and allow the system to move freely. Utilize the stopwatch to accurately calculate the time it requires for the pendulum to complete 10 full oscillations. It is essential to remember that the period of oscillation of a pendulum, which is equivalent to 2p multiplied by the square root of the ratio of L over G, signifies the time taken by the pendulum to complete one full oscillation. When determining the period by utilizing a stopwatch, it is considerably more straightforward to calculate the duration taken for the pendulum to complete 10 full oscillations and subsequently divide this total time by 10, the number of oscillations, thereby obtaining the period t, which is measured in seconds. Having determined the period of the pendulum, we can subsequently derive the frequency of oscillation, which is defined as the reciprocal of the period and indicates the number of oscillations per second executed by the pendulum. The unit of measurement for frequency is hertz. Let us proceed by taking a dynamometer, calibrating it precisely to 0 and suspending it securely from the support rod. Following this, we attach a small weight and determine its mass by carefully observing the weight force indicated by the dynamometer. Subsequently, we substitute the earlier mass with the newly measured one. In doing so, the length of the string will stay unchanged. We continue by repeating the experiment, utilizing a protractor to adjust the pendulum to an angle that is less than 15 degrees and then permitting the pendulum to swing freely. We measure, with the aid of a stopwatch, the duration required to complete 10 entire oscillations. By meticulously recalculating the period and frequency of the pendulum's oscillation, the experiment thus facilitated the experimental determination of the oscillation period of a pendulum for relatively small angles and demonstrated how this is dependent solely on the length of the string and the acceleration due to gravity. Professors, thank you. See you at the next experiment.